Hey guys, in this video I am going to teach you how to find a constant rate of change and slope. So first of all, what does that even mean? The rate of change or slope of a line is the ratio of the change in y values to the change in x values in a linear relationship. That probably doesn't clear things up too much better, so let me simplify that a little bit for you. It will tell you which direction your line will slant as well as how steep it is, which I'll explain more in a little bit. It will also be constant as long as your graph is a straight line. So if the line isn't straight or changes at any point, then there would not be one constant rate of change or slope of the line. You can kind of think of this like if you're a skier, think of the slope as like going down the mountain. Obviously, a mountain isn't the same steepness all the way down. It might change, but just kind of gives you like a little context to what we're talking about, how steep the line is. And that's what we're going to be calculating. So there are a few different types of rate of change or slope that you could have in a line. You might have a graph that looks like this first example, example 1. This is showing what we call a positive or increasing slope or rate of change. And that's positive because it's going up as time increases along the x-axis. Temperature also increases along the y-axis. So both of those variables are going up and up and up and up. The second graph, if you see, is going down. So this is a decreasing or a negative sloping line. And this is because as time goes on, as time increases, the temperature is decreasing. So that would look like, that would be what a negative sloping line would look like going down. And then this last one here is a little bit different. You can see time is continuing on, but the temperature is not changing at all. There is no change or no slope to the line, so this is a slope or rate of change of 0, staying steady. You might remember from the quiz that one question asking about what section of the graph is the student standing still. So that would be an example of what this would look like. Time is continuing on because we can't stop time, but the temperature doesn't change. So that is a rate of change or slope of 0. A couple things, just kind of some notation. This is a little bit of shorthand, kind of like a little abbreviation almost. When we calculate rate of change or slope, it's a ratio. So if I go back really quickly, the key from this first part of the definition is that it's a ratio of the change in y values to the change in x values. So a ratio, we know a ratio is something like this. Since it says y to x, the y values would come first and the x value would come second. But it's not just a y value, it's the change in y value. Remember from previous discussions, change in math means the difference. So we're actually trying to calculate as the line changes, how do the y values change in relation to the x values. So it's important to know that it goes in this order, y then x. And I point that out because oftentimes the biggest mistake we make is that we write our ratio backwards. So let me go forward again. So this triangle is a little short notation. In science and math, it means change. So this is just a short way of saying what I wrote in the definition, the change in y over the change in x. So the important thing is when we write the ratio with the slope or rate of change, we always write it as a fraction rather than writing it as the way that some of you might be more comfortable writing them side by side. We're not going to write our ratios like that. We're going to write them as fractions. But like I said, it's mostly important that you put the change in the y values on top and the change in the x values on the bottom. Again, most common mistake is flipping those two around, which I'll go into when we do a few examples. Okay, so how do we write this ratio? We know that writing ratios can be fairly simple, but this is not quite as easy as just writing two numbers on top of each other because we need to calculate the change between the y values and the change between the x values. So we need to actually look at two or more different y values and figure out how much it has changed from one to the other before we can write that down in our ratio. So let's take a look at this example. Here is a line. You can tell. One thing I like to do before we start calculating rate of change or slope is just kind of look at the line, the graph, or the table and decide, is it increasing or is it decreasing? So if you look at this line, it's obviously decreasing, so we already know that my answer should be negative because it's decreasing. So when we calculate the change in y values, we first need to figure out what our y coordinates are on the graph. So this point right here is 2, 5. So my y coordinate here is 5, and this point is 3, 0. My y coordinate is 0. So remember, we're going to write our ratio as the change in y over the change in x. This is tricky because in our ordered pairs, the x value comes first. So we're almost looking at our ordered pairs backwards. We're using the second value first, and then we're looking at the x values, which is the first value. So if our y values are 5 and 0, I want to know what's the change between them. Now, I like to go from left to right, so going down since the graph is going down. So from 5 to 0, that is a decrease or a change of 5. Since it's decreasing by 5 points, I'm going to write that y value has a change of negative 5. So from positive 5 to 0, the change in the y values is negative 5. Now let's look at the x coordinate. We started at a positive 2, and then we went to a positive 3. That is an increase of 1. So on the bottom, since it's increasing by 1, we're going to put a positive 1. And then there's my ratio, negative 5 over 1. And then if I can, I simplify that. You could leave it like that, or you could just simplify it to negative 5. So this graph has a slope or a decrease of negative 5 for every one x value. Let's try another example. This example, we have to be a little bit more careful because a few things we need to look out for. Number one, this graph has labels along the x and y axis. If you noticed, our previous example had nothing. It just was a regular old coordinate plane, nothing special. This one is relating to the distance driven. So you can see our x coordinates represent time in hours, and our y coordinates represent distance in miles. So this first point right here is 460. My second point on the graph is 870. Okay, so remember, our line is increasing. So this means we should know that our answer should be positive. So that way we know if we made a mistake if we don't get a positive answer. All right, so we're going to write our ratio is the change in the y values over the change in the x values. So if I look at my y values, again, remember our ordered pairs, the x comes first and the y comes second. So 60 to a 70, that is an increase of 10. So our y values have a change of positive 10, or just 10. Our x values go from positive 4 up to positive 8. That is a change of a positive 4. Now in this case, you are going to simplify your fraction or your ratio by dividing 10 by 4. If you divide 10 by 4, you get 2.5. I'm going to write this down here. So 2.5. And then with this example, we actually need to include units in our answer, sort of like a unit rate. So this is 2.5. Now what we need to realize is that we did the change in the y values first, and the y values represent miles. So the change of 10 is a change of 10 miles. A change of 4 on the x-axis was in 4 hours. So this is 10 miles every 4 hours, which simplifies to 2.5 miles per hour. And that is our rate of change or slope for this practice problem. Let's take a look at another graph. This example, as you can see, is decreasing. So we know just by looking at it, our answer is going to be negative. See, it's going down. So when we calculate our rate of change or slope, we're going to make sure our answer is negative. So this graph actually has 3 points on it. The rest of them have only had 2. So what you are going to do is you're going to pick which 2 points you want to use. So the first one is 0.16. This one is 1,010. And this last one is 2,000, 4. So it actually does not matter which 2 of the 4 points, or excuse me, 2 of the 3 points you use. You can use the first and the second. You can use the second and the third. You can use the first and the third. Why it doesn't matter is because our line is constantly decreasing at the same rate. It doesn't get any steeper. It is continuously decreasing at the same slope. So it does not matter which points we use. So let me switch colors just so you can see which ones I'm going to use. I'm just going to go ahead and use my second 2 points for no reason really, just because. So remember, we're going to look at the change in y values over the change in x values. So the y values go from a positive 10 down to a negative, or excuse me, down to a positive 4. So since it's going down, that's a decrease of 6, a negative 6. And again, this is, if you look on the y-axis, we're talking about temperature in degrees Celsius. So that is a decrease of 6 degrees Celsius. And then the x-axis is actually increasing from 1,000 to 2,000. So that is a change of a positive 1,000, and we're talking about altitude. So altitude is how high you are up in the sky. If you ever have gone hiking, you might notice that the higher you go up in altitude or elevation, the colder it gets. So that is what this problem is representing. So this says that negative 6 degrees Celsius, the temperature drops 6 degrees Celsius for every 1,000 meters that you climb. Again, you can simplify this by dividing -6 divided by 1,000. That will give you a change of negative 0.06 degrees Celsius per meter. And that is your rate of change or slope. Okay, so I'm going to stop this video here. I'm going to start a second video just to keep this one not from going too long. So those were a few examples of how to use a graph to calculate the rate of change or slope of the line. And then in the next video, I'm going to show you how to use a table to calculate the rate of change or the slope of the line.